Yes, so here's an example. Y is equal to x squared minus 2x no, that's the assignment, sorry. Given the function y is equal to x squared minus 2x minus 3, you have to copy and complete the table by substituting the x values into the equation. And one is done for you already, you can prove it. Complete the table. Part B, to draw the graph, okay, using the scale that is given there. Plot the points and so forth. On your graph, draw the line of symmetry. And write down the coordinates of the y-intercept and the minimum point, and write down the roots. The roots are on the x-axis, that's when y is equal to 0. Okay, so therefore now you have an example. Y is equal to x squared plus 2x minus 8. So A now is a positive 1. So when we sketch the curve, when we draw the curve, we're going to get a U shape, okay? Because A is positive, a positive 1. If you don't see a coefficient, there's an invisible positive 1 there. So we have to complete this table, and we did it already by substituting -5, -4 up to 3 into the equation. And to get the range, these are the y values. And with the -5 and the 7, the x and the y, we create points. Okay, x comma y, that's how you represent a point. The x coming first and the y coordinate coming after. And as you can see, this was done. All right, and we're moving on now to plot the points now. Okay, so here we have the points. So we're going to demonstrate how the points are plotted on the x and y axis in order to draw the curve. Okay, so here's a copy of the curve, which is already sketched already, but you can actually see how this can be done. Okay, the first point is -5,7, -5 on the x and +7 on the y. Okay, -5,7. So you're going to plot -5,7. So what we do basically, we look for -5 on the x. There is -5. Okay, look, -5. So let's use our guideline. That's -5 on the x right there. And we look for +7 on the y. So that's 5, 6, 7. So let's look for +7. Okay. So that's 5, 6, 7. And right there, the first point was plotted. Okay, the next point is -4,0, -4 on the x and 0 on the y. So we first have to look for -4 on the x. That's -5, so look -4 right there. And 0, so we're on 7, so let's come down. 6, 5, 4, 3, 2, 1, 0. On the x-axis, y is equal to 0. So -4,0, here it is. Let's move on to -3, -5. So let's look for -3. So we're on -4, -3 on the x, and -5. So we're on 0 now. So we're going down to -1. Okay. -1, -2, -3, -4, and -5. Okay, so right here, where those two lines intersect, the vertical and the horizontal, that is where we have -3, -5. Okay, so we're going to plot this point, -3, -5. So that's what you do basically. Create those points on your table and plot it. Always remember x coordinate comes first. Next point, -2, -8. Okay, so we're going to look for -2 on the x. Look, -2 on the x and -8 on the y. So we have to continue going down. We're -5, -6, -7, and -8. All right. 5, -6, -6, -5, -6, -7, and -8. So look, -8 right there. Okay. So you plot that point. come down to negative 8. That's negative 3, so let's come down to negative 8. Right there. Okay. Let's move on. Negative 1, comma negative 9. So negative 1 on the x. And we just have to go one more to negative 9 because we're negative 8. So negative 9 coming right there just before negative 10. Okay, right there. And then we plot that point negative 1 on the x and negative 9 on the y, right there. Right? Actually, this looks like the roots. Remember, y is equal to 0 for the roots. If you look at the question, it says write down the roots where y is equal to 0. So negative 4, comma 0 is like a root already, and 2, comma 0 is like a root. All right, so all where y is 0, this is called a root. All right, so you can write root there one time. When y is equal to 0, you can write root. Once y is equal to 0, you can write root. Once y, you see y, when y is equal to 0, that is where you have a root. That's on the x-axis. Y is equal to 0 on the x-axis. Please take note of that. Okay, so look where we have a root right there. Look like we have a root right there. Okay. Look like we have a root right there. So let's just color code it to indicate a root right there. Okay. If you want, you can increase the size to 2. Okay. Point 2. Okay. So on the x-axis, you have roots, bear that in mind. So look like we have a root right there, negative 4, comma 0. Okay. And this looks like the minimum point, right? See, the lowest point on the graph is the minimum point. As you can see, this looks like the minimum point. All right, the lowest point on the graph looks like the minimum point. Okay, so always you can take note of that. Minimum point right there. Okay, on the graph. That's the lowest point. As you can see, the graph does not go down any lower. Okay, that's the minimum point. So it's coming down with the minimum point and then it's going back up. And look like there's another root, 2, comma 0. Bear in mind, we identified it on the table of values. Or where y is equal to 0, you have a root. Bear that in mind. Okay, so that's just information. Let's continue plotting. We plot negative 1, comma 9, which looks like the minimum point. All right, negative 1, comma 9 looks like the minimum point right there. All right, so you can take note of that. Just like the graph doesn't go any lower than negative 9. So you see it going back up. Okay, so that's the minimum point. So you're going back up to negative 8 and negative 5, 0, and back up to 7, 7, 7. Okay, so we're going back up now because the graph has reached its minimum point. So it's 0, comma negative 8. Oh, and that's the y-intercept right there. All right, 0, comma negative 8 is the y-intercept. Okay, so look, we have the y-intercept right there. So as these are key points we identify on the graph: the roots, the minimum point, and the y-intercept. Okay. Right there, the y-intercept. Okay. 0, comma negative 8 right there. And then we're moving on to 1, comma negative 5. 1, comma negative 5. So x, moving on to x, look for x equal to 1 on the x-axis. And we're going up now to negative 5. Because we reach a minimum point, which is negative 9. And we're going up to negative 5. Okay, negative 8, negative 5. Okay. We're moving on. Yeah, up. Right there. Good. Okay, the next point. 2, 0. Ah, that's a root where y is equal to 0. It's called a root. Okay. Where y is equal to 0 is called a root. You can follow with this. Right. So that's another root. So 2, 0. Okay. So look for 2 on the x. And then 0, that's on the x-axis. Y is equal to 0. And then the final point now is 3, 7. Okay. So we look for 3 on the x-axis and 7 on the y-axis, right there. Good. And then we have another point, 3, 7. Right there. And already the curve has been drawn already. The points has been drawn for this. All you do now, you just take your free hand and you join the dots, make a nice curve. They call it a parabolic curve. This one is a U shape because the value of A is 1, a positive 1. And once the value of A is a positive number, you're going to get a U shape, which of course that's what we did. And that's what we got for this example to sketch the curve of y is equal to 1x squared plus 2x subtract 8. -8 is the y-intercept. -4, 0, 2, 0 are the two roots. The minimum point is -1, -9, and the y-intercept is 0, -8. By the way, that's x equals 0 right there. All right, bear that in mind. Parabolic curve, a U shape because the value of A is 1.